16. The volume of gas produced by the reaction of 100 centimeter cube hydrochloric acid with excess calcium carbonate is excess, is measured in two experiments. The volumes of gases are measured at RTP room temperature and pressure, and the results are shown. Time, volume of gas in experiment 1, in experiment 2. So this increasing here constant, increasing here constant. Experiment 2 produces more volume of carbon dioxide gas. So you are asking, which one change in condition to experiment 1 gives the result for experiment 2. Experiment 1 you give less volume of gas, experiment 2 you will get more volume of gas. So if you use a higher concentration of the acid is used, so you will get more volume of oxygen as calcium carbonate is excess. So answer is B. A higher concentration of acid, then more calcium carbonate will react and volume of gas will be more. So you are asking which one change in condition to experiment 1 gives the result for experiment 2. If in experiment 1 if you use more concentrated hydrochloric acid, then you will get experiment 2 result. That means more volume of gas will be produced. Now 17. Hydrogen is made industrially by the reaction. Carbon monoxide reacts with steam to produce carbon dioxide and hydrogen. Delta S, this reaction is exothermic reaction as delta S value is negative. So statements about this industrial process are given. Which statements are correct? Here 1 and 3 are the correct answer. Why? You see, a high pressure can be used to increase the rate of formation of hydrogen. A high pressure, yes. If you use pressure increases, molecules become closer, more successful collision occur, rate of reaction increases. So 1 is the right answer. And 3 is the right. Why? A high temperature can be used to increase the rate of formation of hydrogen. Yes, if you increase temperature, rate of reaction will be increases. 1 and 3 is the right answer. But why 2 and 4 is wrong? A high pressure can be used to shift the equilibrium to the right. No. 1 mole, 2 mole, 1 mole, 2 mole. Pressure have no effect because there are same number of moles on both sides. So 2 is the wrong. Now why 4 is wrong? A high temperature can be used to shift equilibrium to the right. No. As reaction is exo, so at high temperature equilibrium will shift from right to left. So this is wrong. 1 and 3 is the right answer. Next, the table refers to two important industrial gaseous reaction: hydrogen, nitrogen product ammonia, catalyst nickel, no catalyst nickel. This is wrong. Catalyst will be iron. And oxygen, sulfur dioxide, this is true. Vanadium 5 oxide catalyst is used. So which catalyst are correctly stated? reaction 1, this no, this is the right, because here not nickel, iron catalyst used in manufacture of ammonia by Haber process when hydrogen reacts with nitrogen. Reaction 2, when sulfur dioxide reacts with oxygen to produce sulfur trioxide. So in this reaction vanadium 5 oxide catalyst is used. This is true. So B is the right answer. Next, 19, iron 2 ions reacts with chlorine. Which statement about this reaction is correct? Here iron 2 is oxidized, chlorine is reduced. So chlorine is reduced by iron 2 ions. Yes, this is true, because iron 2 ion reduces chlorine but itself oxidizes. I mean, chlorine is reduced by iron 2 ions. That means iron 2 ions reduces chlorine to chloride ion. Why? You see, this is oxidation number 0, this is -1, this is iron 2 plus oxidation number +2, this is oxidation number +3. So iron 2 ion is oxidized, chlorine is reduced. Iron 2 ion reduces chlorine to chloride ion. A is the right answer. Why B is wrong? Chlorine is reducing agent. No, chlorine is a oxidizing agent, because chlorine oxidizes iron 2 to iron 3. This is wrong. Iron 2 ions are reduced by chlorine. No, this is wrong. Iron 2 ion is oxidized, not reduced. Wrong. D is iron 2 ions are oxidizing agent. No, iron 2 ion are reducing agent, because iron 2 ion reduces chlorine to chloride ion. So iron 2 ion is not oxidizing agent, iron 2 ion is reducing agent. B, C, D wrong answer. A is the correct answer. Now 20, which reagent and observation describe the test for the reducing agent? So acidified potassium permanganate 7, it will goes to purple to colorless. So any reducing agent, if you add to acidified potassium permanganate, reducing agent reduces potassium permanganate, so color change will be purple to colorless. That means KMnO4, this is purple color, So if you add any reducing agent, reducing agent it will go to colorless. Reducing agent potassium permanganate goes to manganese 2 ion. Manganese 2 ion is colorless. So how can you test for reducing agent? Reducing agent is added to potassium permanganate, acidified potassium permanganate. Potassium permanganate turns purple to colorless. This is the test for reducing